Hello and welcome to another video on the compilation process. In this video we're going to briefly look at semantic analysis and how it fits in with the compilation process. However, going back to our compilation process, we can say that the compilation process consists of lexical analysis, symbol table construction, syntax analysis, semantic analysis, machine code generation, and code optimization. In previous videos we have looked at lexical analysis and symbol table construction, and we've also looked at syntax analysis. In the previous video we looked at syntax analysis, so let's have a quick recap of what that's all about. So syntax analysis is about checking the grammar of the language. It's about making sure that the words are in the right order regardless of the meaning of those words. So in a programming context, normally we say name equals Bob, and that would translate to a variable equaling some sort of literal, a word, a number, true or false, whatever that literal is. However, a grammatically incorrect way of writing that would be to say Bob equals name. A compiler does not like this. Okay, any compiler would say, nope, that's not good. That's an error. I'm going to throw that error to you and say fix it before we move on. And the way that would look would be literal equals variable. And the syntax analyzer takes all of your code in the form of tokens, numbers, that represent different keywords, and it creates something called a syntax tree. Now, you don't need to know a lot about how syntax tree works. All you need to know is the order with which things are done, generally speaking, for the syntax of the language. What do I mean by that? Well, take this equation very quickly, 2 plus 3 times 4. We can interpret this in different ways. We can say 3 times 4 plus 2 is 14, or we can say 2 plus 3, which is 5, times by 4 is 20. And we say to ourselves, if we're a computer, well, which one of these is it? I don't know what you want from me. So syntax analysis is about making precedence an important factor. What do I mean by precedence? Well, BODMAS. This has a higher precedence than O. D has a higher precedence than A. That means we multiply and divide before we add and subtract. So that means we do this first, then this, and I've created two different trees that represent these two different ways of representing this equation. You don't need to know how these work for your GCSEs. However, this just exists to help illustrate what I mean by making sure that things are in the right order, otherwise you get incorrect results. So, that is syntax analysis. But we now move on to semantic analysis. Semantic analysis. What is that all about? Well, we've gone through 3 different stages so far in our compilation process. We've gone through lexical analysis, which is about making sure the words exist in our language. We've gone through syntax analysis, which is about making sure those words are in the right order. And now we're on to semantic analysis, which is about making sure that those words make logical sense, that we can have meaning from those words. It's about making sure the relationships between those words have suitable meaning. So once all the grammar rules have been checked, we need to check whether the code makes logical sense. What's a very simple way of checking that the code makes logical sense? Well, one very important example is something called type checking. And type checking is a very important part of programming. It doesn't so much happen in Python as it does in other languages, because other languages force you to tell the computer which type it actually is. You'll have seen this in your pseudocode when you're doing stuff like define x as integer. This is giving x a type. Remember, an integer is a whole number like 3 or 6. And you tell the computer up front, yeah, x is going to be an integer. If you don't do this, it's up for grabs a little bit more to the compiler. And it's still important that we make sure whenever it sees x in your program and you haven't said it's an integer, that it makes sure whenever you refer to it that the types are compatible. What do I mean by this? Well, let's say x is 3 and then I decide to do y equals x plus 4. What's the result? Well, 3, which is x, plus 4 is 7. So I get the result 7. Yep. Now, let's say I had y equals x plus Bob. Now, mathematically, this makes absolutely no sense. There are different ways we could go about this. We could say, well, the result probably would be 3 Bob. But does that make mathematical sense? No, it doesn't. It makes grammatical sense. This follows the grammar of the language perfectly, but it does not make semantic sense. It does not make logical sense. So what we say is, if we encounter this kind of error in our program, where you try to add a word, a string, to an integer, we say, whoa, hold on there, that is actually a semantic error. It's a logical error. I can't do this because it's impossible as a logical thinking machine to add a word to a number and get a meaningful answer. So what we say is we have mismatched our types, and you can do this with a lot of different types as well. You could try doing a float and trying to add it to a boolean. You could try adding a character to a integer, for example, very similar to what we've done here. Sometimes, depending on the language maybe, a character and a string are incompatible, but usually this would be fine because a string is just a bunch of characters put together. So a computer, most of the time, like 95% of the time at least, would say this is fine. But generally speaking, otherwise, we need to make sure the code makes logical sense, and type checking is just one way of going about this process. Now, I'm not going to cover any more on semantic analysis because there are so many different ways that a computer can check whether or not something makes logical sense. If you're interested in that, there's certainly plenty of resources on the internet that you could use. All you need to know for semantic analysis is that it checks to make sure that the program makes logical sense. It needs to construct meaning out of the keywords that you use, the literals and the variables and all the rest of it, and it makes the relationship and the meaning of stuff clear. If there are any errors, it throws an error at you and says fix it before we continue compiling. And what you'd do at this point is you'd start back from the beginning and recompile from the start up until the point is finished. If the problem is fixed, it moves on. If not, it tells you to redo the process again and again. That's what compilation processes do, unlike interpreters which let you do it line by line. So that's it for semantic analysis. That's a very short video. Next video we're going to be moving on to machine code generation. So thank you very much for watching, and I'll see you again next time.